Good morning, girls and boys. Now, imagine that I have one of those old-fashioned manual typewriters. I insert a large roll of paper and then give the typewriter to a chimpanzee. And let us assume that the chimpanzee will begin typing, and at random, tap, tap, tap. What would happen? Well, in all probability, we would have a page of gibberish. But could that chimpanzee, by chance, type something like a sonnet by Shakespeare? Say, "Shall I compare thee to a summer's day?" Now, for that to happen, the chimpanzee would need to type an S for shall, and then, by chance, an H, and then an A, SHA. Now, if there are 26 letters, 10 numbers, and say 9 other keys, such as shift, arrow, space, or tab, let us say 45 keys in total, if all keys can be hit randomly, then for the chimpanzee to hit SHA, the probability will be 1 over 45 times 1 over 45 times 1 over 45. The probability of that happening is 0.0001%. But now the chimpanzee has to type the L, followed by another L. Now that will give a probability of 0.00000054%. It is unlikely to happen. But boys and girls, it is not impossible. And one can argue that in theory, if one waited long enough, the chimpanzee would type, "Shall I compare thee to a summer's day?" And later, "Thou art more lovely and more temperate," and so on. The point is, it's not impossible. It is, of course, very, very unlikely. Indeed, the chance of its occurring during a period of time hundreds of thousands of orders of magnitude longer than the age of the universe is extremely low. But it is not zero. Now, in mathematics, this business of the typewriter and the monkey is called the infinite monkey theorem. And I think I was about 10 years old when it was taught to me by one of my first maths teachers, and it has stayed with me for a long time, as has the whole notion of probability. It is such a fascinating topic. I used to teach mathematics and to all different age groups, but vividly one afternoon, it was in F4, I remember I was teaching maths to year 3, and I remember giving each pupil in the class a pound coin. I think there were 18 students in the class, and I made a deal. I said that in a moment I was going to ask them one by one to toss their coin. And if we got 18 heads in a row, I would take my clothes off and run around Bushy Park in my underwear. Now, of course, the class got very excited by this, but the question is, was I on safe ground? If this were a bet, would you take it? Is it impossible to get 18 heads in a row? Well, no, it's not. 18 independent events, each with a 50% probability, so it's half times a half times a half, and the chances, in fact, of that happening are 0.0015%. In other words, it is very, very unlikely. Actually, in the event, the class did become very excited as the first 4 or 5 children who tossed their coin did indeed get ahead. But eventually we had a tail and I was safe. Some of your parents may play the National Lottery, and here there are 49 balls. In fact, I think there are 59 balls now. And you need to choose 6 balls to win the jackpot, usually worth many millions of pounds. Choose 6 numbers. Well, people talk about their lucky numbers, and of course this is statistical nonsense. But let's say you choose 6 numbers, say 4, 17, 26, 38, 42, and 49. And let's say I'm going to choose the first 6 numbers, 1, 2, 3, 4, 5, 6. You might say, and many would say, "Oh, that's ridiculous. Those winning numbers are never going to come up 1, 2, 3, 4, 5, 6. But of course, my selection of 6 consecutive numbers has exactly the same chance of your 6 chosen numbers coming up. It seems counterintuitive, but it is true. And now for one of my favourites, and it really is extraordinary, and it's called the birthday problem. If I have a large party of, say, 20 people, what is the probability that 2 or more people share the same birthday? If there are 366 days in a year, if we allow for a leap year, what do you think? I have 20 people at my party. Will 2 or more share a birthday? Now, I can't go into the maths right now, but the probability, in fact, with just 23 people present, is about half-half, 50%. Now, there are 366 dates. So how is it possible that with only 23 people present, there's a decent chance, 50-50, of 2 people sharing a birthday? And I have to say, in 30 years of looking at class lists of school children, and even discounting twins, I've noticed, often to my amazement, that in about half the cases, 2 unrelated people in the class share the same birthday. It is kind of amazing, though it does make mathematical sense once you delve into this a little bit. It's even more remarkable that with 50 people at a party, the probability of 2 or more people sharing a birthday is around 97%. And with 70 people, remember, there are 366 days in a year, a full year, but with 70 people, the probability rises to 99.9%. It's almost bound to be the case, and if it were a bet, it would be worth taking. Now, if, like me, you enjoy numbers, permutations, and patterns, you might want to think about a career in financial markets or perhaps in insurance, where mathematicians are called actuaries, and perhaps becoming an actuary is something that would interest you. And this brings me to today's date. It is the 23rd of June, which happens to be the birthday of the great British mathematician Alan Turing. And if you've ever been lucky enough to see a £50 note, you'll see that he is on the back of it. It was Turing who, during the Second World War, did such remarkable work in building a computing machine to break the Enigma code by a process of statistical analysis. And thus he helped to end the war much earlier than it might have done. And it's been calculated that through Turing's knowledge and application of mathematics, he helped to save the lives of many millions of people. Now, the challenge for the British High Command was that they now knew when and where the German attacks were going to take place because they'd broken the code. But they could not, in each case, notify the ships, as this would give away the fact that the code had been broken. And so, on purpose, they had to allow ships to be sunk and people to be killed. But of course, they wanted to save the greatest number of lives overall. And again, mathematics was used to calculate how often they could save the most number of ships from being torpedoed without the Germans becoming suspicious that their code had been broken. It was a finely balanced mathematical exercise and literally one of life and death. All these documents were strictly classified after the war, and this has only now recently come to light. And finally, girls and boys, I can share with you that today it's also my own birthday, along with Alan Turing's. Now, what are the chances of that? Have a good day, everyone.